Welcome to The Explainer. Today, we're talking about Sentinel. And this isn't just another platform for automating job sites. No, this is about giving those sites an AI that can, get this, actually predict the future.
All right, to really get this, we have to start with a problem, one that's pushing the absolute limits of both human safety and, well, economics. We're talking about remote work sites in Western Australia, where some pretty essential jobs are just becoming way too high risk for a person to do. I mean, it's gotten to the point where regulations are actually making it illegal for a person to stand there with a simple stop/slow sign on any road over 60 kilometers an hour. Why? Because the risk of getting hit by a car is it's through the roof. And if that wasn't enough, the cost of just putting people on these sites has completely skyrocketed. You factor in wages, penalty rates, the flights, the housing for this fly-in, fly-out kind of work, and you're looking at a single human crew costing a company over $5,500 every single day. So that leaves you with this massive question, right? How do you build the future when you literally can't fill the jobs you need today? When a job is too expensive, too dangerous, and you can't find anyone to do it, you need something totally new, something way beyond just giving someone a joystick to control a robot from far away.
Okay, section 1. Let's talk about the perfect storm that really kicked all of this off. We're diving into Western Australia's resources sector because that's where this unique crisis really lit the fuse for this whole new idea. So the people who designed the system, they call it a trilemma. And it's a great word for it, right? It's a three-sided problem with no simple fix. You've got spiraling costs, you can't find nearly enough people for the jobs, and the government is stepping in and saying, nope, the old way is just too unsafe, it's illegal now. And this chart just lays it all out, doesn't it? The industry is staring down a massive shortfall. We're talking over 10,000 workers short. At the exact same time, costs are exploding, and these new safety laws are dropping. It's the definition of a perfect storm. It makes automation, well, it's not just a nice-to-have anymore. It's an absolute necessity. All right, section 2, the cognitive shift. Now, Sentinel's first crack at solving this problem was pretty good. But their second idea, the one they pivoted to, that's where things got really revolutionary. So at first, the plan was to build what they called a universal translator. A system that could just control a bunch of different robots. But then the team had this huge realization. The real game changer wasn't just showing an operator what's happening right now. The breakthrough was building a cognitive system that could predict what's going to happen next. It's the difference between a dashboard and a crystal ball. Okay, section 3, and this is where it gets really cool. This whole cognitive shift, it's all possible because of something the creators called the imagination engine. And what powers this engine? A really groundbreaking piece of tech called a world model. Now, a world model is totally different from the kind of AI you have on your phone. That AI, it predicts the next word in a sentence, right? A world model predicts what happens next in the real world. It has this sort of internal understanding of physics. It knows that a wet road means less friction, so a big truck is going to need more space to stop. And that ability to actually understand and predict reality, that's been the missing piece of the puzzle for true industrial autonomy. And here's how it all comes together in what they call the imagination loop. It's incredible. The AI is constantly running this cycle. First, it perceives the world around it, building this 3D map. Then it predicts thousands of possible futures. Then it simulates its own actions inside all of those futures to see what would happen. And finally, it picks and executes the absolute safest path forward. And the craziest part? It does all of that in under 120 milliseconds. That's literally faster than a human can blink. It's superhuman speed. Okay, section 4, the squad in action. So we've talked about this incredible AI brain. Now let's see how that translates to an actual physical team out on the work site. So the system isn't just about one robot. It actually orchestrates a whole squad. You've got a Tesla Model Y, which is basically the mobile command hub and the power source for the whole operation. Then there's the humanoid robot, the H1. It's the flagger, and they chose a humanoid shape for a good reason. It commands more respect from human drivers. And finally, you have this little four-legged robot, the Go-To, acting as a scout, constantly patrolling and keeping the AI's map of the site perfectly up to date. And this scenario just shows you the raw power of this thing. So picture this. In a test, the Tesla's cameras spot a car barreling down the road at 110 kilometers per hour.
In just 2.5 seconds, the world model predicts a collision is about to happen. A tenth of a second later, bang, it triggers the Tesla's horn and flashes the high beams. Another tenth of a second after that, it commands the humanoid robot to jump out of the way. The entire sequence is over before a human operator could even realize there was a threat. All right, section 5. Now, deploying technology this powerful in critical infrastructure, roads, mines, that kind of thing, it brings up a huge, huge security challenge. You have to build a zero-trust robot. So when they did a security assessment on the robot hardware itself, well, they found some pretty critical vulnerabilities. We're talking about things like hard-coded passwords that you can't even change, and totally unencrypted communications. A hacker on-site could, in theory, take control of the robot. And that's not just a data breach, that's a kinetic threat. That's a real physical danger. The solution they came up with is pretty radical, actually. You just don't trust the robot. At all. The whole system architecture is built to treat the robot as if it could be hostile. So it's totally isolated on its own network, no internet access. Every single command gets sanitized through this secure digital airlock. And as a final failsafe, there's an independent hardware kill switch that can instantly cut power to the motors, completely bypassing the robot's own software. Okay, last section, the 5-year future. Because once you have this kind of secure by design foundation, well, it lets you build an incredibly ambitious roadmap for what autonomous work is going to look like. And you can see the progression here is really clear. They're starting in 2026 with what they call AI guardrails. So a human is still in control, but the AI acts as a safety net to prevent mistakes. Fast forward to 2028, and the robots are doing the heavy lifting themselves, like setting up traffic cones all on their own. And then the big goal, by 2030, is the invisible supervisor. That's one person managing over 20 sites at once, because the robots can actually talk directly to approaching smart cars using what's called V2X, or vehicle-to-everything technology. The worksite itself starts talking to the cars. And all of this leaves us with a pretty big final thought. What Sentinel is doing, it isn't just about making roadwork safer. This is a blueprint for pretty much any industry. Mining, construction, logistics, anywhere that predicting what happens next in the physical world is the key to a whole new level of safety and progress. So it really poses this powerful question. When an AI can genuinely imagine the future consequences of its actions, what else becomes possible?